Oh man, finishing already? Oh shit, my hair looks so fucked up. Oh well, it's so annoying though. They look okay now. Hmm. Screw it. I'm so cautious about my hair and how it looks like. Because right now it looks like shit. Hmm. What if I were to take my camera? Oh shit. Hmm. Interesting. I mean, it's not bad, to be honest. Looks kind of good. Looks kind of alright, in my opinion. Hmm. Interesting. Well, I mean, looks good enough, I guess. So annoying. It's gonna disconnect soon enough at one point. Me adjusting this. Hmm. Yeah, screw it. My hair still look like shit, but alright. Guess I'll have to work with what I have. It's all good.
Tin, Metal Road, Fast. Saya buka penjelaran. Include. Je. Mesti kena masuk lalu you learn kot. So, baru boleh tekan ni. Kalau tak, tak ada kan? Stem 2, 2004. Okay. Dia ada lah BM, BI. So, siapa yang ada masalah dengan tak faham bahasa Inggeris, bolehlah pandang kepada BI. Salah. Apa tak faham bahasa Inggeris, berpandang BM. Saya proceed terus kepada BI. Okay, so ni adalah, biasa soalan pertama adalah chapter 3 lah. So, kalau ikut daripada sini, mestilah dia macam ni kan. Factory, produce, metal, road, use in construction, quality check. Based on 95% pass. So So, kita belajar dalam chapter ni ada dua. First, kita belajar yang ni lah. Kan? Tapi soalan biasa dia problem solving question. So, saya rasa ni dah tak masuk lah. Tapi bolehlah tengok balik macam mana cara buat ni. So, ni kalau ikutkan ada yang kita belajar. Kalau ada contoh kita nak cari, ada something yang kita tak ada dekat probability tu. Ingatlah balik. Total macam ni kan, N. Tak ada. So maksud dia, satu tolak lah. Satu tolak. Nanti dapat jawapan N tu. Lepas tu inilah yang ni.
I don't get it. What you trying to
Pro
say?
use in construction quality check based on 95% pass. So, kita belajar dalam chapter ni ada dua. First, kita belajar yang ni lah. Kan? Tapi soalan biasa dia problem solving question. So, saya rasa ni dah tak masuk lah. Tapi
Serius lah. Ni tak masuk. Ni apa? 2024-2025. Tak masuk.
bolehlah tengok balik macam mana cara buat ni. So ni kalau ikutkan ada yang kita belajar. Kalau ada contoh kita nak cari, ada something yang kita tak ada dekat probability tu. Ingatlah balik. Total macam ni kan, N. Tak ada. So maksud dia satu tolak lah. Satu tolak. Nanti dapat jawapan N tu. Lepas tu inilah yang ni, kembangkan. Kalau dia adalah P, X greater than 1, less than equal to 3. Maksudnya dia nak PX sama dengan 2 dengan 3 lah. Betul tak?
Betul.
Tengok dekat simbol ni, ada sama dengan ke tak?
Tak ada.
Bila tak ada, maksudnya tak include, not include.
Bisa dilepas.
Macam tu. So ambil lah daripada jawapan dekat sini. Tapi saya rasa apa yang dah masuk test, saya rasa tak ulang lah. So korang double check lah. Yang mana dah masuk test. Hari tu test kan?
Ada dia.
Yang label tadi, label dia.
So dia tak berulang lah. Okay, so biasanya. Okay, dia akan either binomial ataupun Poisson. So ingatlah binomial kita berkaitan tentang success and failure. So dia ada dua case, success and failure. So kalau ikut daripada yang ni, dia ada cerita success failure lah, betul tak? So dia kata based on record 95% pass. Ni success lah ni. Success tak semestinya positif ni lah, ingat balik tau. Okay, not necessarily is a good thing. Tu cuma dalam kes kita sekarang ni adalah tentang pass. So dia adalah a positif lah. So sekali kita punya P adalah 0.95. Ni adalah binomial lah kiranya, sebab dia tentang success failure. And kita ada 15 and then Q kita adalah, macam cek Q?
Tu tolak P.
Tu tolak 0.95.
0.5. Okay, dah settle list out ni, barulah kita boleh nak go for question. So the first one, exactly metal road pass. So dia same dengan kita punya claim, kita punya success. Pastikan dia kena sama lah. So bila dah sama, barulah kita boleh buat follow NPQ yang kita list out. Ini kira lah. Ini boleh guna table kan? Kalau
Exactly 14 metal rods plus the test. So
dia ada selain daripada pakai NCX tu, boleh pakai table kalau ada. So ada ke tak table dia?
Dia 16 dengan 20
Kosong point P adalah kosong point 95 kan?
Betul.
0.95 and then N kita
kosong point 95.
adalah
15.
15. So carilah N15 dulu.
Okay, N15.
Dekat sini. Lepas tu kita nak untuk 14. Jadi
Kenapa 14? Oh, exactly 14 metal rods passed the test. So, okay, makes sense. So only 14 passed. Right. So if I want to check, this is for the binomial distribution. What we do, we find the sample which is N15, right? So we go to the 15, which is right here. And then of the 15, 14 of them has passed the test. So we go 14 right here, right? And then we have to use the 95% of the broad passed the tensile test. So 95, 0.95, right? So 0.95 is right here, and the answer is 14.366.
Scroll. And then dapatlah nilai dia.
366
Ya ke?
Betul lah.
Betul.
Hmm.
0.366.
So, macam mana tadi jawapan?
Tak payahlah nak kira dah. Terus dia tulis jawapan 0.366. Dapat 2 markah.
0.366 Kenapa kosong?
Mana dapat 2 markah? Sebab ni.
Tu je.
Equal.
Okay. At least 12 metal rods pass the test. Okay. So sama je kita apply yang ni, tapi we will follow the 12, 1, 2, 3, 4, the fourth one, right? And then 0.95, 1, 2, 3, 4, 0.031. Oh, at least 12 metal rods though. So that changes, right? At least. So P at least. $12, $13, $14, $15. So it's more than or equals to 12. I'm pretty sure.
And then
Let's see if I'm correct.
kalau 3 maksudnya tulislah simbol ni dulu. Apa at least? Ni pass juga kan. So okay, pakai sama, P dengan Q yang sama. So at least apa?
At least tu
Apa?
Greater than equal lah.
Greater than equal. So kalau greater than equal, kita akan dapat apa?
12 sampai 16.
16.
15.
Letak 16.
Yes,
12.
13.
So P x 12 plus P x 13 plus P x 14 plus P x 15, right? So do I have to like search one by one? That's what I'm understanding from this, right? So 12 would be 0.031, 0.031 plus 13 is 0.135, 0.135 plus 14 will be 0.366, 0.366 plus 0.463. I think that has to be the answer. Zero point 995. Think that's the answer.
14. 15. Mana nak tahu stop sampai mana?
Dia punya sampel tu, N tu kan.
Ya, dia punya sampel ni. Tu cara kita nak tahu kita stop. Okay, less than pula. Kalau less than, X less than 13. Kalau less than 13, maksudnya kena start daripada 0, 1, 2, 3, 4 sampai
Sampai
13.
dari 0 sampai 12.
12.
Kita buat sampai 12.
So less than 13 means damn, zero also counts.
Tapi you either you buat sampai ni ataupun you buat 1 minus. Yes, 1 minus. So yang kita tak nak adalah start daripada 13,
15 sampai 13. Sama tu.
14, 5. Ni yang kita tak nak lah. Ni yang kita nak 15. So cari lah 13, 14 dengan 15 punya. Kita dapat jawapan apa? Saya bincang dia punya cara je. Dia cari jawapan. So nanti nak tahu jawapan betul ke tak, sila buat semua dan bagi pada saya untuk semak.
Less than 13 metal rods failed the test. Less than 13. Less than 13. So more than 12 metal rods passed the test. So 13, 14, 15, right? Because the logic behind this is the whole thing, if we add up all together, is coming to 1, right? So less than 13 metal rods failed the test. Okay, this part I don't understand already. Okay, instead of trying to understand this, we'll come back to this later. So far, these two I think I understand, so we're gonna stick to that. Yeah, we are going to stick to that. More or less. More or less.
Okay? Okay, ada soalan?
Ada doktor.
Settle. So, kalau logiknya kalau dah yang first adalah binomial, obviously yang the second one adalah ini sebab ada perkataan average, so automatic dia dah jatuh kepada Poisson lah. The second thing yang kita belajar adalah ni, mean ni ada tak dia bagi dalam formula? Nanti dah check juga. Benda-benda mean, variance, standard deviation ni. Ada yang bagi, ada yang tak bagi.
Dalam soalan ada bagi
Tapi
doktor.
itulah, tengok dalam tu. Tak ada, dia dalam yang table saja. Sekejap, tadi kita dah terjumpa dah. Tengok ni, ni fail lah. Tak
Sudah.
boleh lah guna ni.
Sudah.
Sekejap.
Sudah.
Guna tu boleh. NPQ kena tukar. N kekal 15. P kita sekarang ni dia dah kena terbalik. 0.05. Q kita adalah 0.95. Ini okey. Ini okey je, tak ada masalah. NPQ tu kena write dulu. The new NPQ. Okay? Sebab ni fail.
Makes sense. So okay. So with that logic, right? 0.05. That makes no sense. Is that the answer though?
Sebab tu apa-apa pun bila binomial kena pastikan tengok betul-betul. Dia follow dengan yang atas ataupun dia berlawanan. Bila berlawanan ni.
Doktor.
Ya.
Skrin doktor tak gerak pun.
Gerak.
Okey.
Gerak.
Bergerak.
Tadi doktor macam explain tak ada kan? Ke doktor memang tak tulis?
Saya tak tulis, saya sebut. Fail, nampak kerja saya? Kerja saya nampak tak?
Nampak.
Kita tadi tak perasan tu. Apa-apa pun bila buat binomial, mesti pastikan ni. Dia follow sama macam yang atas ni. Kalau dia berlawanan, apa yang kita kena buat adalah kita kena write a new P dengan Q. Macam mana nak tulis, terbalikkan je P dengan Q yang kita asal tu. Okay, sebab sukses kita sekarang ni dah bertukar kepada word fail. Okay, sukses kita. So berlawanan kepada sukses fail adalah pass tadi tu lah. Okay, kena tukar ni dulu. So table pun kena tengok P 0.05. Ni. Faham tak? Kenapa pentingnya kena tukar? Kali ni kita kena pakai yang 0.05, cari masih lagi dalam yang 15 ni. Kita nak tadi 13 kan? 13, 14, 15. Suhu 0.000.
Kosong.
Kalau siapa yang tersalah tengok, dia akan ambil lah nilai yang belakang ni. 0.135, 0.366, 0.463. Tu kalau orang yang tak faham lah, dia akan buat yang tu. So which is salah lah, faham tak? Beza kan? Jawapan dia 1. Dia bagi jawapan dah. Jawapan dia 1. Okay, tengok markah pun dah tahu dah. Mesti banyak step dia. Markah pun 5. Okay. Proceed next.
Ya boleh. Okay, medium.
Okay, next. Macam saya cakap, kalau dah first one adalah binomial, maybe the second one tu dah mula untuk poison lah pula. Okay, so poison.
Macam mana tahu soalan tu binomial ke poison? Macam poison, kalau soalan ni poison dia bagi tahu poison. Yang tu.
Ni mana ada? Dia tak cakap pun ni Oh mana ni? Oh ni ada. Ya.
Yang ni ada poison.
Ni ada poison.
Satu tu kita nak tahu dia binomial ke poison. In case lah dalam masa exam nanti kan.
Tengok dia ada dua kemungkinan probability ke tak. Macam success failure macam tu lah. Kalau binomial dia mesti dua je kemungkinan dia tu. Success failure, dia tak boleh 3. Dia tak boleh maybe, tak boleh. Dia mesti it's either jadi ataupun tak jadi. Macam tu. Tak. Keyword dia kena tengok dekat sini lah. Biasa dia akan bagi percentage ni lah. Kalau tengok soalan yang yang
Sudah.
sekejap, saya tengah nak cari lagi 1 tahun. Kalau ikut logik, ini binomial ke poison?
Binomial.
Kan? Sebab first
Percent.
Okay, first percent. Lepas tu dia berkaitan tentang contaminated ataupun not contaminated lah.
Yeah.
So itulah binomial. Macam ni pun poison tak semestinya tau. Okay, saya beritahu lah, tak semestinya dia mention ni adalah poison distribution. Kalau pembuat soalan tu dia baik hati, dia akan letak lah perkataan poison tu. Kalau dia saja nak test student faham ke tak, ini adalah poison, dia takkan letak. Okay, so sendiri kena tahulah. Okay, so poison pula, apa yang penting kalau poison? Kalau poison apa yang penting?
Average.
Per. Okay, per ni. Average okay. Per ni. Per apa? Tu penting. So dia kata average dia, mean dia adalah 3 untuk 100 meter. Ini kena keluarkan statement ni dulu. Okay. Lepas tu baru kita tengok exactly to defect 100 meter. So dia follow lah. Dia follow mean yang sama. Jadi kita dah boleh terus pakai lah. Exactly tu sama dengan 2. So ni boleh tak kita pakai table? Poison pun ada table juga. Ni kan. Mean tadi 3. Mean 3. Ni. Mean 3. Ada mean 3. So boleh juga pakai table je terus. Mean tau. Mean dia 3. So 3 lepas tu kita nak tadi 2 kan. So dapat 0.2240. Terus dia dapat jawapan 0.2240. Semudah itu. 1 minit je boleh jawab. Tak 1 minit. Setengah minit kot. Okay, Atmos. Atmos simbol apa? Atmos.
So mean is equals to 2 defects per 100, right? So exactly 2 defects. So mean is 3. So 3, then of the 3 to 0.224. At most, 1 defect occurs in a 50-meter steel plate. So 50 meters steel plate, right? So 3 100 na 1.550. Wow. So this time instead of 3, we have to go to 1.5, which is right here. This mean so 1.5 at most. So at most 1. So 0 1, right? So I need to calculate 0 as well, right? So 1.50 is 0.2231 plus with 0.2347. Five something.
Less than equal.
Less than equal. 1. Okay. Less than equal 1 tak ada masalah lah. So less than equal 1 kita akan, tapi again, pandang pada per ni, in 50 meter. Macam mana nak ubah? Supaya mean kita this time dah jadi 50 meter.
Bahagi 2.
Bahagi 2. Kan baru dapat ni. So kalau 3 bahagi 2 dapat
1.5.
1.5. So kita akan pakai mean nanti adalah 1.5. Lepas tu, okay, yang ni kena kembangkan macam yang sebelum ni lah. P sama dengan 0 tambah P sama dengan 1. Okay, lepas tu boleh pakai table ke? 1.5 ada kan? Ni 1.5. 0 dengan 1, so 0.2231 tambah dengan 0.3347 lah. Okay. So 3 markah tu adalah tukarkan mean yang baru and then kita cari dalam table pada mean yang sepatutnya lah. Nilai dia tu.
Faham.
Dan ni, simbol ni. Okay. Saya ingatkan lah. Kalau kita punya tu adalah at least. So let's say soalan adalah at least one defect. Kita tak ada limit ni sekarang ni. Binomial tadi
At
ada
least.
N. Tapi kita tak ada ni. Siapa yang kita nak kena buat?
So 1, 2, 3.
Tu
Satu
tolak.
tolak lah.
Ya. Dia
Tu
mesti
tolak.
buat satu tolak. Bukakan balik kepada dia punya ni lah. So dia akan jadi P satu tolak dengan X sama dengan kosong.
X is bigger or equal to 1. So 1, 2, 3, 4, 5, 6, 7. So the other side of that is just 0. Right? Okay, makes sense.
Okay. Ini highlight lah
Hmm.
untuk peringatan semua. Hope this time dia tukar at least kan. Hope lah. Okay, lepas tu dah boleh masuk dalam chapter 4. So chapter 4 kita belajar apa pula chapter 4?
Continuous probability distribution.
Chapter 4 kita belajar normal. Continuous probability distribution. Okay, so kita belajar normal distribution. So dalam normal distribution kita belajar first untuk population. Lepas tu kita belajar untuk sampel. This time korang ada belajar untuk sampel. Pastikan kita identify case yang mana satu. So sekarang soalan Texel is not follow the normal distribution with mean and standard deviation. So random, selected, sample grade. Then, sekarang cara kita nak tulis P X greater than 675. Lepas tu kita kena tukarkan jadi Z. So bila tukar jadi Z, 675 tolak
600
bagi
bagi 50.
bagi 50. Saya ingatkan lagi sekali. Dan
Mechanical engineer is testing the testosterone of a new alloy used in manufacturing aerospace. So it's greater than 675, right? So that's equivalent to Z bigger than 5 minus.
kadang kita tak terus direct bagi standard deviation. Boleh jadi dia bagi apa tu?
Percent.
Variation apa? Variance.
Variant.
Okay, variance. Variation pula. Variance. Okay. So macam mana cara nak dapat, tapi mesti kena tukarkan kepada standard deviation. Tak boleh terus ambil nilai variant. Macam mana nak tukar kalau dia bagi variant? Kena square root kan?
Punca.
Ya, punca kan? Barulah dapat standard deviation. Sebab kat sini mesti standard deviation, bukan variance. Okay? Lepas tu kira lah macam biasa. Table macam yang kita buat graph. So graph kita sekarang untuk normal
Standard deviation. So for standard deviation, how you search? Basically, right. So 675 minus 600 divided by 50, 1.5. Right. So,
okay, untuk normal area sentiasa pada sebelah kiri. Area sentiasa pada sebelah kiri, tapi soalan kita nak greater than. Maksudnya loritkan kita, cuba kirakan kejap. Z dapat apa?
1.5. Bigger than 1.5.
1.5.
1.5.
Hmm.
So 1.5 kalau ikut sini kosong, 1.5 ada kat sebelah kanan.
Mm-hmm. Kosong.
So kita akan loritkan kanan. Jadi apa yang kita kena buat sekarang ni, kita kena buat reflection. So reflection dia akan reflect menjadi negatif 1.5. Area at the end kita sebenarnya nak jawapan probability which is the area. So tak perlulah buat satu tolak, faham tak? Kita just terbalikkan je. Dia jadi Z less than negative 1.5. Kita terbalikkan sahaja. Bila masa kita akan kena buat satu tolak? Bila masa kita kena buat satu tolak? Bilakah? Bila? Apa? Bila area kita tu besar macam ni. Bila kita buat lorik. Contoh dia nak P Z PZ less than. Okay, PZ less than 1.5. Yang tu kita kena buat satu tolak. Lepas tu kita carilah nilai untuk negatif tu.
Tolak ke? Doktor, yang doktor lukis ni kenapa 1.5 tu kena pindah sebelah kiri?
Sebab table kita lorik semua sebelah kiri.
Oh, memang tak ada belah kanan ni.
Tak ada. Table yang kita ada tu memang semua lorik sebelah kiri. Dia nampak ni macam tak bagi bincang. Ada ada saya cakap dalam bahasa Melayu kan. Ada international student ke? Ada kan?
Yes, me.
Oh, siapa?
Ada saya.
Is there any international student?
Ada. Semua Melayu Alhamdulillah kat sini.
Okay. Tak, saya speaking. Dan saya, dia dah start balik. Sorry lah. Teaser.
Tak baik 5 ni.
Apa ada member ni? Oh, baru soalan nombor 1. Yelah, pizza pun 2 jam setengah kan. Ya. Okay, so table ada ni lorik dia tu kat mana, nampak lorik dia tu. Kalau yang positif pun lorik dia macam ni, nampak tak Faiz, warna biru ni. Nampak
Okay. Nampak.
Tapi yang kita nak yang sebelah kanan ni, which is kita kena, tak payahlah, yang ni boleh lah buat satu tolak. It's either you reflect, okay, then you cari 1.5, negatif 1.5 jawapan dekat sini. Jadi 2 cara lah kiranya. Either kita reflect, so kita cari itu, ataupun kita buat satu tolak. Ini kena buat satu tolak sebab kalau nak direct guna positif punya ni.
One second. Kita dasar. Boom. Let's get back to work. All right.
Okay, at the end kita akan dapat jawapan yang sama juga. So let's try. Kalau kita buat directly P PZ
I just want the answer, man.
1.5 is 0.0668.
Why? Yeah? Why?
Yeah.
Okay. So
Okay.
daripada table negatif 1.5 adalah 0. Ujung kanan.
Kenapa? Kenapa ujung kanan?
1.5 is 0.0668.
Okay. So that influences, right? Right. So it's 0.0668. Right, that makes sense. Okay, got it. Makes sense.
Betul.
Ataupun satu lagi cara kalau tak nak buat yang reflect, kita buat satu tolak. So bila kita buat satu tolak Z greater than 1.5. So this time satu akan tolak kepada
One minus 9.332. Zero point zero six. Okay. Bob.
less than 1 minus betul greater than less than. Okay, less than. Lepas tu dia akan jadi 1.5. Ni yang 0.9 mesti kena tukarkan kepada Z dulu. Kita dia daripada tukar Z, kita nak cari jawapan dalam table, betul? Pastikan area yang kita nak tu samalah dengan apa yang kita nak cari tu. Okay, so yang ni pun akan samalah. X 550 dengan 620. So tukar jadi Z. Okay, cuma yang ketiga ni. Obviously, you learn the next subtopic adalah berkaitan tentang sampling. Mestilah kita test juga kan, takkan tak test. This one.
1.6 je.
She didn't show, that's the thing. So annoying. The hell.
Lima lapan kosong.
Kita kena cari standard deviation yang baru, which is standard deviation kepada sampel. Okay, kena cari yang baru, standard deviation. So just standard deviation population divided by square root of n, the number of sample. Ini yang, so kita akan pakai formula ni. Faham? Tu je ubah. Jadi ni kalau ikut case kita sekarang ni, apa yang kita nak jadikan Z kita? Mana kira kita nak tulis? First kita ada X less than 580. So nak tukar kepada Z akan jadi akan jadi apa? Akan jadi
580.
Okey.
Tolak dengan 600 rupiah tadi atas. Tolak 600
Okey, tolak 600
bagi 50
bagi 50 over square root 60.
Betul.
Sini dapat apa nilai dah? Negatif kan? Negatif berapa?
Negatif 1.6.
Negatif 1 point
1.6.
1.6 je.
Negatif
Mana?
1.6.
Dia tak ada, dia 2 decimal places ke?
Dia 1.6 je.
Negatif 1.6.
Negatif 1.6.
Betul.
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 Cek. Oh, soalan yang tadi tu salah. Oh, ni lain. Tak sangat soalan. Jawapan tu. Betul-betul. Dia ni. Okay, negatif 1.6. So, yang ni direct je lah. Terus guna je ni. Apa?
Standard distribution, so negative 1.6. 0.548. That's it.
Check.
The fuck?
Jawapan daripada table tu. Tak perlu buat satu tolak. Settle. Chapter 4. Next adalah chapter 5. 8. So check.
Damn, that's it? That's how she ended it? Goodness gracious. I'm so worried. As in, what if they ask a different type of question, you know? Is there another exam paper that I could refer to by any chance? What time is it now? 1:15. How long have I been streaming already? Let's just check. 1 hour. Right. So I'm gonna get about 15 minutes of break. Well deserved or not, I don't care. So now is, let me just show you the time. Right. So right now is 1:15, if you can see. So I'll be back in 15 minutes. So 1:30. I'll be back by 1:30. Right. I think I should also off the mic. I'm back. All right, fair enough. I'm about 8 minutes late-ish. But we'll take a piss. Right. So I'm not done with the question yet, obviously, but um, let's get back to it. Let's just do question one. Okay, so question one, yeah. A factory produces metal rods used in construction. Each rod must pass a quality check for tensile strength before it can be shipped to customers. Based on records, 95%. So P, we have P, Q, and N. So P is 0.95, Q is 1 minus 0.95, which is 0.05. And then N is the sample, 15 rods. So 15 rods. That's all we need to know. So, first question, which is exactly 14 metal rods. Pass the test. So the keyword is exactly. So px is exactly 14, right? So if p is exactly 14, what we do, we need to use the formula, which is right here. All right. Oh yeah. So we must first go through. Oh, okay. So this first question is binomial distribution, right? So from here we can tell the sample size is 15. So we must go here, which is 15, and then uh, the p is 0.95. So we go 0.95. And now the sample is 14. So we just go to 14. So the answer is 0.366. That's it. It's pretty straightforward. It's easy to understand. Moving on to the next question. Okay, so the second question is at least 12 metal rods pass the test. At least 12 metal rods pass the test. So at least 12, meaning x is smaller than or equals to 12, at least. Sorry, it's bigger than. Yeah. No, it's at least 12. So it has to be 12, 13, 14, 15, right? So x is bigger or equivalent to 12, which also means px is equals to 12 plus px is equals to 13 plus px equals to 14 plus px equals to 15. Am I right? Yep, I'm right. So, same thing. We must use the formula just right here, right? Uh, the n, which is 15, p is still 0.95, so we just have to write down 12, 13, 14, 15, which is 0.031, 0.031 plus with 0.135 plus with 0.366 plus with 0.463, right? So the answer is 0.995. Am I right? Yes, I'm right. Good. So now the third question is less than 13 metal rods fail the test. Now this is crucial because earlier P, Q, and N is 0.95, 1 minus 0.95 equals to 0.05, and N is 15 rods. So this is for success. However, failure is very different because it failed, right? So 1 minus 0.95, okay. So less than 13, less than 13, smaller than 13. So that means it's like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 12, right? So instead of doing that many, we just need to focus on 13, 14, and 15, right? So that also means 1 minus x bigger than 13, which is 1 minus px equals to smaller than 13, so it's 12. right? It has to be 12. 13 minus px 14 minus px 15. Now, why this changes is because now the sorry, the sample is still 15. However, the p is now 0.05. So we have to stick to 0.05 this time, right? So 13 is 0.000 minus 0.000 minus 0.000. So the answer is 1. That's literally it. Am I correct? Booyah! Correct. Let's go. So question 1A. I think I know how to do it. So far so good. Right. Now, question 1B. Let's focus on this. Let's have a look. Again, if I could solve this question, okay, if I can solve question 1 without issues, I can end the stream and take as long as a break I want before I live stream again for question 2. Right? That was the deal. That was the deal. Right, let's go. So, question 1B. Oh, yeah, who texted me? Let's check on that real quick. Okay, let's go. Yeah. That's cute. Macam bodoh je. Question 1B. In a metal fabrication plant, it is found that on average, 3 defects occur. Okay. On average, 3 defects occur per 100 meter. So that's 3/100. This is the mean. Right? So we're going to use this. Okay. So first question is exactly 2 defects per 100-meter steel plate, right? Exactly. So px equivalent to 2. This one, same thing, very simple, very straightforward. We are going to use the formula sheet, but this time for Poisson distribution. I don't know if you can see this, but it says here Poisson distribution. So this is what we're going to use, right? Now, so for this, we already identified that on average 3 defects occur per 100 meter. So that is the median. We're going to use that. Okay, that is how we're going to use measure the scale. Now, exactly 2 defects per 100 meters steel plate. Now, according to this Poisson distribution, 3 is the defect, right? So here, as you can see in the table, we have the number 3, which is right this side with my pinky finger right there. Yeah, that's 3. So 3.0. There is no decimals. So 3 defects occur per 100. We're going to follow this 3. And now, for this specific question, exactly 2 defects. So x is 2, exactly 2. So 3.02, the answer is 0.2240. 0.2240. That's it. That's it. So freaking easy. It could not be more easier. It's so goddamn easy, right? It's so simple. It's almost impossible to screw it up. Now, second question. At most, 1 defect occurs in a 50-meter steel plate. Now, this is where you need to pay attention because 1 defect occurs in a 50-meter steel plate. Now, the question provided 100 meter. So if it is 50, so the mean, which is 3 per 100, we need to downsize it to 1.5 per 50 so that it matches with this question, specifically asking for a defect occurring in a 50-meter steel plate, right? So now we are going to use this new medium, which is no longer 3.0, but it is 1.5. So at most 1, right? So at most is 1. So it's either 1 or 0, right? So px is at least, at most, right? So x is greater than or equivalent to 1, right? So that means px equals to 0 plus px equals to 1. So we have to find 2. So now here in this context, we have to follow 1.5 this time. All right, so 1.5, which is right here, 0 and 1, 0 and 1. 0.2231, 0.2231 plus with 0.3347. Right, so we're gonna sum that up. Plus with 0.3347, we get 0.5578. Is that the answer? Everybody correct? That's it. Fantastic. We got the question correct. Question 1 and question 2. One is binomial and another one is Poisson, which is easy. Right. Something's fishy, but this will do. So far, so good. It's pretty easy stuff. Hopefully. Now, moving on to the third question, which is question 1C. Okay, so a mechanical engineer is testing the tensile strength of a new alloy used in manufacturing aerospace components. The tensile strength is known for follow normal distribution mean. Okay, so the mean is 600 MPa and standard deviation, which is also square root of variance, which is equivalent to 50 MPa. Find the probability that a randomly selected sample has a tensile strength greater than 675 MPa. Okay, so here it gets a little bit trickier, right? So it's greater. So px is greater, right? So it's greater than 675, which is equivalent to pz. The x, you have to replace it with z, and then the 675 minus with the mean divided by standard deviation, which is 50. Six seven five minus 600 divide 675 minus 600 divided by 50, we get 1.5. Now, usually in the standard deviation chart, right, the Lorekan, it has to be on the left side. So if this is 1.5, this is negative 1.5. So PZ negative 1.5, that has to be the answer. Now, same as all the previous questions, we must refer to the formula that has been given, which is the standard deviation chart. which is around here somewhere. Let me just check it out. Okay, so this is the standard deviation chart. Negative 1.5, it falls right here, and it is 0, 0, so the answer is 0.0668. Is that the answer? Beautiful, it is the answer. Great. Now the second question is the strength of a specimen falls between 50 MPa and 620 MPa. So oh shit. So P550x 620. Now for this one, however, how do you... Oh shit. Now for this, however, we need to figure out how to calculate between and steps. Oh shit, I dropped my phone. So this is chapter 4. Okay, right. So in this case, how I must write is mm, right. So P 50 minus 600, right? I'm assuming 50 that 620 minus 600 divided by 50. 550 minus 600 divided by 50, which is -1. So -1 z 620 minus 600 divided by 50, we have 0.4. Right. So P z is greater than -1. It has the minus. Is that what it is? Set 0.4. Now PZ1 minus PZ 0.4 Right. So this got easier, I would assume. So in this context, we still have to use the chart right here, right? So now Z is 1, right? 1. So 1.000. Okay, so it is 0.8413 minus off with 0.4, which is 0.6554. Mm-hmm. 0.8413 minus off with 0.6554. 0.1859. Now, I don't know if this is the correct answer, but if I did it all correctly, this should be the right answer. So, hopefully it is, I suppose. Now, the last question is question 3. If a random sample of 16 cells, if a random sample of 16 specimens is selected, what is the probability? What is the probability that the sample mean tensile strength is less than 580 MPa? So less than, right? Less 580. PZ is less than 580 minus 600 divided by 50 divided by, if I'm not mistaken, n, right? Sample size 580 minus 600 divided by 50 per square root of 16. Okay, negative 1.6. Okay, yeah. So he said negative 1.6. So negative 1.6. The answer is 0.0548. 0.0548. Let's go! Beautiful. I just finished question 1. And I think, wow, I'm hungry. So, okay, correct. Beautiful. I think I got it all correct. I hope so. Well done. I just completed question 1. I think I did a pretty good job, and I spent about close to 2 hours understanding question 1, which is a good amount of time, I would say. So, yeah, good job. Pat on the back, I guess. Question 1, I think I am good to go. Just in case, I will redo it again later or something like that. But right now, I'm gonna end the stream. So I have managed to complete question 1. I think I understand it pretty. I have a good grasp of the concept. So I think I can move on. Let me just go through it again. Just 1 second. Yeah, I think I'm good to go. Yeah. pretty straightforward. Yeah. Right. Doable. Okay, so I'm gonna end the stream right here. See you guys shortly. I don't know, maybe 3 o'clock or 4 o'clock. Pretty much. Peace.